Okay, number 25. We have for f of x is 1 over x and g of x is square root of x minus 1. Write the domain of f composed with g of x in interval notation. So f of x is 1 over x. G of x is square root of x minus 1. So we need to write the domain of f composed with g. So first we need to know what f composed with g is. So that's f of g of x, and that's f of square root of x minus 1. Alright, and that's, take that, plug it in there, that's 1 over square root of x minus 1. So how many times have we seen problems like this already? Alright, square root of x minus 1 is fine if x equals 1. Then you have square root of 0 is 0, but it's not fine here because it's in the denominator and we can't have a 0 denominator. So x cannot equal 1. Alright, and also square root of a negative number isn't going to be good. So we have to have a positive number under there, right? This has to be positive. So x minus 1 must be greater than 0. That's another way of saying it's positive. And x has to be greater than 1. So the domain is from 1 to infinity, not including 1. Alright? Alright, number 27. For the following exercises, find functions f of x and g of x. So the given function can be expressed as h of x equals f composed with g of x. Alright, so what is he talking about? Well, let's see. We've got h of x is equal to the quantity x minus 5 cubed. Alright, so what we want to do is write this as a composition of two functions. In other words, f of g of x. So you have to give the functions f of x and g of x for that to work. Alright, so if g of x were equal to x minus 5 and f of x was x cubed, right? In other words, if you plug in x minus 5 into x cubed, you would get h of x, wouldn't you? Yeah. So that's one way of doing it. So we'll say f of x is x cubed and g of x is x minus 5. Alright. Now you can get pretty ridiculous with these. I mean, you can come up with all kinds of crazy functions and they'll work, you know, when you put them together as a composition. Yeah, you can do that if you want to, but I'm a lazy mathematician, so I'd rather do it the easy way. Alright. So that's one way of doing it. That seems to be a pretty easy way to me. Okay. Okay, number 29. H of x is 4 over the quantity x plus 2 squared. Okay, so let me write that down. H of x is 4 over the quantity x plus 2 squared. Alright. So what we want to do is write h of x equal to f composed with g. And you have to give f of x and g of x for that to work. So if you took x plus 2, you could go like this. F of x is 4 over x squared, and g of x is x plus 2. That's one way of doing it. All right. So if you take f composed with g, that would be f of x plus 2, and then plug the x plus 2 here, and you would get that. There's another way you could do it. You could have 4 over x. Let me separate these, because these are different f of x's here, and g of x's. And g of x is x plus 2 quantity cubed, squared rather. Alright? So you take that, put it in there, and you end up with h of x again. Alright, so that's at least two ways of doing it that are pretty simple, straightforward. So there's probably all kinds of oddball functions you could give where that would work. Alright? So anyway, those seem to be the easiest two that I can think of. Okay, number 31. H of x is the cube root of 1 over 2x minus 3. Okay, so one way we have to write h of x equal to f composed with g, and we have to supply f and g to make that work. Alright, so f of x could be, I'm thinking already of cube root of x. Alright, f of x is cube root of x, and g of x would obviously have to be 1 over 2x minus 3. Okay, so that seems to be a straightforward way of doing it. Okay, number 33. We have h of x is the fourth root of 3x minus 2 over x plus 5. We have to write h of x as f composed with g, where we supply f and g. Alright, so I'm already thinking f of x is the fourth root of g of x, which would be the radicand. Alright, so that would be a very obvious, straightforward way of doing it. F of x is fourth root of x, and g of x is 3x minus 2 over x plus 5. Right there. Alright. Number 35. H of x is square root of 2x plus 6. Okay, so we have to write h of x as a composite function, f composed with g, and we supply f and g to make that work. So again, we can have f of x equal to the square root of x, g of x equal to 2x plus 6, oops, not 3. Or another way to do that would be f of x, let me put that like that, I don't want to confuse these two, make that square root of 2x, And g of x could be x plus 3. So when you take f of x plus 3, you plug in the x plus 3 right there, and it's going to be 2 times parentheses x plus 3, which is 2x plus 6. All right? So that's another way of doing it. Okay, we have 37. H of x is cube root of x minus 1. And we need to write h of x as a composition of f with g, and we supply f and g. Alright, so here's a nice obvious one. F of x is cube root of x, and g of x is x minus 1. So when you do this composition, it'll give you h of x. You could also have, get a little tricky here, and you could do this. F of x is cube root of x minus 1, and g of x is just x. Alright, so when you plug that, when you take f composed with g, it's going to be f of x, plug in x there, and you'll get that. Alright? So it's like, you may as well just call this equal to f of x, and this is actually called the identity function. And it's sometimes abbreviated capital I of x equals x. In other words, it'll give you back exactly what you put in. This thing that goes inside there is called the argument. It'll give you the argument of the function back again. So what you have here is f composed with the identity is the same as f of x. You could do that the other way too. You could take the identity function and then compose that with f, and get f back again. So if you take this and plug it in there, right, that's doing it this way. I compose with f, or we're calling g I here, alright? You're going to get I compose with f, so that's, take that, put it in there, you get f, right? So I is kind of like the number 1 in multiplication, alright? And there are parallels here, right? F times I, you can think of that as f times I equals f, I times f equals f. Think of that as f times 1, right? It's a different, though, its composition is different from multiplication, but I has the same effect in composition as the number 1 does in multiplication, alright? Does that lead you in other places? Yeah. When you take linear algebra, alright, you're going to find matrices, and matrices can be associated with functions. And matrix multiplication is weird when you first do it, but it's designed to make stuff like this work, right? So if you wonder, when you take linear algebra or study matrices and you wonder why do they define multiplication like this, it's kind of really, I mean, different from addition or subtraction, all right? Addition or subtraction of matrices is pretty straightforward, but multiplication is a whole different story, and you wonder, why do they do that? Well, it's to make these kinds of things work, all right, and make it consistent. So think of it as another kind of multiplication, all right? Yeah, it's pretty cool how that works. Very consistent throughout mathematics. All right, so it's brilliant. It's all brilliant. Extremely brilliant. Well, let's move on. Okay, number 39. H of x is 1 over the quantity x minus 2 cubed. So we want to write H as a composition F with G. So we supply F and G to make that work. Alright, so if you have 1 over something cubed, right, that something could be G of x, and F of x could be 1 over x cubed, right? So F of x is 1 over x cubed. G of x is x minus 2. Can you think of another way right off the bat? How about 1 over x and the quantity x minus 2 cubed? That would work too. And number 41, we have h of x is square root of 2x minus 1 over 3x plus 4. So we need to write h as a composition of f with g, and we supply f and g to make that work. So we can take f of x is square root of x. This is pretty straightforward, the way I'm going to do it. And g of x is 2x minus 1 over 3x plus 4. There you go. Okay, number 43. For the following exercises, use the graphs of f, shown in figure 4, and g, shown in figure 5, to evaluate the expressions. So we have a couple of graphs that they give us. Alright. So there's figure 4. This is graph f. And figure 5, which is, they label it f of x, the vertical axis. It should be g of x. Alright. They label the graph correctly, g. Right there. So we need to figure out these values. So for 43, we have f of g of 1. Well, first of all, what's the innermost function value? F of, g of 1. G of 1 is what? If you look at the graph of g, g of 1 is 3, right? Alright, so that's f of 3. And so for f of 3, there's x equals 3, right there, and then f of 3 equals 2. Alright? So that's 2. Number 45. We have g of f of 0. So let's f of 0, the innermost function there. Now you look on the graph of f here. F of 0 is 4. Okay. F of 0 is 4, so that's g of 4. Now what's g of 4? Look on g. G of 4 is right up there. That looks like 5. G of 4 equals 5. So the end result is 5. Okay, number 47, we've got f of 4. So you do the innermost function there first, that's f of 4. What's f of 4? Look on the graph of f here, and there's x equals 4 right there. And what's f, the y value? That's 0. Okay, so that's f of 0. Now look again at the graph of f for f of 0. I think we already did that, didn't we? F of 0 right there is 4. Okay, number 49, g of 0. So look on the graph of g and find out what g of 0 is. G of 0 is 2. Okay, now what's g of 2? Again, look at the graph of g. G of 2, right? There's 2. G of 2 is the y value, which is 0. All right. Okay, number 51. It says for the following exercises use graphs of f of x shown in figure 6, g of x shown in figure 7, and h of x shown in figure 8 to evaluate the expressions. So let's look at these graphs. If we look here, we've got f of x, figure 6, g of x, that's labeled f of x on the y-axis. It should be labeled g of x, okay? They did label the graph g of x right there, so that's good. Figure 7, and then figure 8 should be labeled h of x instead of f of x on the y-axis. But they do have it labeled correctly on the graph, h of x, figure 6, alright? Okay, so 51 is g of f of 2. So find out what f of 2 equals. Look at the graph of f on figure 6. F of 2. What do we have? 2. There's x equals 2 and y equals 4. This looks like y equals x squared, don't it? So that's g of 4 then. Now we find g of 4. So figure 7, you look at g of 4 right there is 2. That looks like the square root function, square root of x, doesn't it? So that's 2. Okay, number 53, we have f of g of 1. So, f of g of 1. What's g of 1? Look at figure 7. G of 1 is 1. Oops, right there. G of 1 is 1. See, there's x equals 1, y equals 1. So g of 1 equals 1. So we need f of 1 now. So that's figure 6. I have a feeling it equals 1, right? F of 1 is 1, right? Okay. Number 55, h of f of 2. So what's f of 2? Let's see, figure 6. F of 2, I got a feeling it's 4, right? F of 2 is 4. Yeah. So that's h of 4. Okay, and what's h of 4? H of x looks like the absolute value function, doesn't it? So it should be 4. H of 4 right there is 4. So there we go. Okay, number 57. F of g of f of negative 2. F of g of f of negative 2. We have 3 opening parentheses, so we need 3 closing parentheses. 1, 2, 3. Alright. So that's going to equal f of g of... Now, we need to find out the innermost value. F of negative 2. What is f of negative 2? Well, I got a feeling that's 4, right? Y equals x squared. F of negative 2, yeah, that's 4. Okay. So now we need g of 4. G of 4 is a square root function, so you take square root of 4, right? But you can look on the graph too. G of 4 is 2, the square root of 4. So that's f of 2. And f of 2, go back to the parabola. Take 2 squared, right? 2 squared is 4, yeah. So f of 2 is 4.